happening on Windows too, apparently.
Just use
Or just use Linux, maybe.
But then I have to reinstall all my games.
Well, no, you just boot from a flash drive if you want.
That means I have to buy a new flash drive.
It's cheaper than installing your games again, though.
This is true. Especially since some of those games don't play on Linux.
Yeah.
Get a consistent USB drive.
All right, so questions, issues, etc. up to this point, other than Window Builder, which we know about.
Oh, so here's a problem for this one.
What do I pass to update again? It says graphics, but I don't know how to get it.
Repaint, you mean?
Is it repaint? Is
Yeah.
that okay?
So if you call repaint, it doesn't need any arguments.
Alright, thanks.
Yeah. Yeah.
I was just wondering, I was having issues, I don't know what's wrong with me, but I couldn't get the mouse positions when I clicked on my J-frame on PI.
Did you get an event to trigger?
The mouse, I did.
Okay.
Anytime it clicked, it would say that, but I couldn't figure out, is there a way to have it print the coordinates to the screen?
Absolutely. So you set up a piece of code that prints or something, right, when you do a mouse click?
Yeah.
So the code, the outline of it was written for you, right?
Right.
So there should be an argument passed to it, right? And it's called like mouse event or something like that, some argument. So that argument will accept methods, or you know, it comes with. Right, the argument's a mouse event object, and that comes with some get methods. So get X and get Y. So here's the setup. I've already got a haha and a ha ha ha, so needed something different. So right click, add event handler. You're doing a mouse clicked?
Yeah, mouse and then, mouse. Yes, mouse click.
Okay, mouse clicked. Okay, so in this case, the argument is arg0. So if we call arg0 get X, and arg0 get Y. So now when you click, you get XY coordinates.
Boom.
There we go.
And then you can do what you like with them.
You get them nifty windows.
Yeah.
That's awesome.
Yeah.
When doing PA3, can we? Are you gonna mess with like? Do we have to be able to have it auto adjust?
Nope. You can make it static.
Okay.
But if you want to figure out how some of the layout managers work, it's a good template to work with.
Would not adjust.
So if you make the window bigger, moves things
okay.
around, makes the playing field bigger, stuff like that.
Is there a way to disable the ability to resize the window?
Yes and yes. There's probably a way to disable it, but you can also pick up when it's resized, and you could just change the size back. Or make it even smaller to like be a disincentive to mess with it.
Send a pop-up message.
Yeah.
It just gets smaller every time.
Yeah, yeah.
Jumanji.
Is it hard to make it to where it resizes every time
No, so some of the layout managers will pretty much do that for you. Right, so if you use like a spring layout,
spring layout or what it says?
so you can put a panel over here.
Like you click on the box thingy.
When they try to make a winning move, it just moves the window. Like every time you just try it.
This was how we got into trouble the other day.
It's a square and makes it the other. It makes it the
one button.
My Siri
There's another button.
ask it like a question, you know, bring
What's
up
that
like
panel
some
that you put in?
Google answer.
It's just a J panel. So I just dropped that in. I set a border so we could see it.
Oh, I see.
Otherwise, it'll be invisible. But you may want to make a separate panel for your tic-tac-toe board.
Inside your J pen.
Yeah. Because here's your frame. And there's a title bar on top. And then most of this is a J panel. But you're going to have buttons for like XO and U first and me first. And maybe a taunt panel or something, whatever else, right? And you don't really want to have to deal with mouse clicks in here and figure out if they're inside the tic-tac-toe area or not. So you can drop a new J panel in here and do all of your drawing in there and pick up all of your mouse events in there. And it's all going to be relative to this.
So that'll have its own X and Y coordinates?
And that'll have its own X and Y coordinates, yeah, as long as you put the event handler off of that object. And then if they click outside, it'll just be picked up by the system.
Where did you grab the JPL? Oh, or the...
It's a container, yeah.
Okay. That's good.
So, well, there are my panels set to be resizable. But let's... And these buttons don't work for some reason.
And the way you did that was by using a spring layout instead of...
Using a spring layout.
Okay.
And this isn't going to be quite right either. Oh, no, that's not bad. Okay. So you can do stuff like that. And if you want to make that panel resizable in both directions, but I don't know if this actually takes, yeah. So you gotta put another one of these constraints in somewhere. Northwest, southeast. But anyway, you can mess with it. There is a way to make it so things shrink and grow. And use a layout manager instead of doing it yourself, unless you really, really, really like writing Java. You can do it yourself. You can, every time the window is resized, you can pick that up and do something accordingly. If you're going to do that, click on the J frame, add an event handler, component resized. And then every time that this changes, you should get events.
What's the at override do?
The at override,
Yeah. Like a bit of code or just like a...
it doesn't really do anything, but it's picked up by the editor to know that there's a default component resized method, and we're deliberately making our own version of it.
Okay.
And there's some tools we can use that take advantage of that.
The at stuff is also for Java doc, right?
Yeah, there's all kind of like meta language stuff. So it's stuff that's not actually part of the Java code itself, but it's picked up by the editor and the other tools and used to do various things like documentation, or know that you're overriding something, or to suppress warnings that you're tired of seeing, things like that. Yeah, you can read all about these things here.
Jeez.
Yeah. All right, yeah, so have fun with the layout. All right, other questions? So we were talking about threads and multi-threaded things. Common area where you're going to find yourself using threads is when you're doing graphics, when you're trying to display information and such. So for example, you want to continually update some information and display some aspect of that information graphically, right? If you write your main program and it's going along and it's doing some calculations and coming up with some new information to display and repeatedly calling repaint, you may or may not actually see any of those updates appear. Okay, because remember, repaint doesn't actually cause any painting to happen. It just issues a request to Swing and says, hey, when you have a chance, please repaint this component for me. But if you have a main program and it's CPU bound and it's just doing something in a loop and you never come out of that loop, you may not get painting events to happen. You may not actually get events to be noticed at all. If somebody clicks on a button, you may not actually end up in your mouse handling code. Okay, so typically graphics things with GUIs, Swing things, the main thread is just kind of sitting idle waiting for events to take place. And inside those events you might do something like update state information, say repaint, and then exit, and then the thing that's doing the actual painting will notice that you asked for a repaint and it'll go ahead and paint your component. But if you're going to be CPU bound, if you're going to have some kernel of code running that's just chunking away on numbers and coming up with new information, it's really good to put that in a separate thread, right? So typically we might have one thread that's doing a bunch of CPU-based calculation, another thread that's doing our painting and drawing, a separate thread that might be processing user input, right? Because user input might come every few minutes. Somebody types something and hits enter. And as we said with lab 3, right, you don't want to sit there, or lab 2, you don't want to sit there and wait for the user to hit enter before you continue your code. So typically we'll see multiple threads when we've got graphics involved. So let's take a look at thread 2. So this is a pretty simple window. It's got a go button and it's got a panel. And let's see, so what are we doing in here? We've got a J panel, we've got a thread called myThread, and we're going to construct a myThread. We've got a size, we've got a me, which is equal to this, so I can talk about myself. And we've got accessors and mutators for this size variable, so we can see what it's equal to, and we can also change it. We've got the usual main program that Window Builder creates for us, right? And this is always kind of what our main looks like. It's a thread, right? This is all sitting in a run method, and something says start, and a new thread's created, and this run method executes. And as usual, the only thing this method does is create a new object of type main, set it to be visible, and then exit. So main does all the window gadget stuff, right? Creates the panel and the J frame and the J button, makes some action listeners. The go button is triggered to this code down here, and basically it's going to create a new thread from the class myThread, and it's going to start it. And the paint method is just going to paint a rectangle at 100, 100, whose dimensions are size and size. Okay, so this is a really simple class. It's got a J-frame. It's got a paint method that will draw a rectangle whose size is given by this variable size. And when this starts, when you hit the go button, it creates a myThread. So what is myThread doing? This is the more interesting one. So it remembers who the parent is, because when we construct the myThread, we pass it an argument of me. Right, we could have just said this. But me is me, right? It's the class, the object that's executing this. So the myThread saves that argument in a variable called myParent, which is an object of type main. So myParent tells this thread who this is, right? Which means we can use the getSize and setSize to change this variable size, which is being used by this variable's paint method. So we have a grow method which takes the current rectangle size, adds 5, and then repaints. And we have a shrink method which takes the current rectangle size, subtracts 5, and calls the repaint method. And then the main method for running basically calls grow 50 times, calls shrink 50 times, resets the size to 10, and just does that forever. So if we run this, we've got our box here, we've got a little rectangle. When you say go, you get a rectangle that's growing and shrinking. Not terribly smoothly, but that's okay.
It's doing its best.
It's doing its best. And if I start up other things on my machine, we can like slow that down or make it jittery and stuff. But we've got multiple threads here, right? This myThread is going through and continually just adjusting the size of that variable size in the main class, and then repainting. And the main class is just dutifully picking up that size, filling a rectangle. Okay, but you can't really make this work if you don't have a separate thread, because you gotta be able to breathe to grow. All right, so with that in mind, let's look at a more interesting example. So our favorite towers of Hanoi. And I'd really like to know why some of my fonts are bigger than others. Like this font's kind of fun to look at, and this one not so much. Nothing's ever flaky in Eclipse though, so I'm sure it's not Eclipse.
No.
It's a feature, not a bug.
Yeah. Helps you know which window you're in. Okay, so remember Towers of Hanoi, right? You have 3 posts, and you have a series of discs. And the goal is to move the discs from one post to another. And you can only move one disc at a time. You can only take off from the top, and you can't have a bigger disc on top of a smaller disc. And we want to move all the discs from here, say, to there. And the trick was, if you know how to move 4 discs, you can easily move 5 discs, because you pick up these 4 discs and move them over to this third pole. And then you take this biggest disc, move it to the target pole. And then you take those 4 discs and you move those over to the target pole on top of the biggest disc, and you're done. So it's a 3-step recursive algorithm. And if you only have 1 disc to move, you just pick it up and move it. Right, that's your base case. So we coded this up last year, and the solve algorithm looks something like this. Right, so solve for a number of disks from pole to the to pole. If the number of disks is 1, we just move from the source to the destination and we're done. Otherwise, we solve the problem for 1 fewer disks, going from the source pole to whatever the third pole is. And then we move the largest disk from the source to the destination, and then we move those num disks minus 1 from the third pole to the destination pole. And third just tells you if your poles are 1 and 2, then your third pole is 0, and so on. It just figures out what the third pole number is. So that's the recursive solution. And this show move used to just say, print out what move you need to make. Okay, so we want to add some graphical elements to that. So we need some small data structures. So I have a 2-dimensional array, polls. And here's the deal, polls, bracket 0, bracket 1, and bracket 2 are each an array of integers telling you which disks are on each poll. And the disks are numbered 1, 2, 3, 4, 5, and so on from smallest to largest. So polls bracket 0 would be an array of the elements 1, 2, 3, 4, 5. Right? And then there's another poll length, which just tells you how many disks you have on each poll. So that's the length of the polls bracket, poll number array. So polls 0 would be 5, polls 1 would be 0, polls 2 would be 0. That's all the structure you need to store everything that you need to know about the setup of the game right now. That tells you how many disks are on each poll and what the identity of those disks are. Right? And each disk is coded by its diameter, effectively. So they have individual identities. So we're going to construct a towers object, okay, which is going to, well, towers is going to be the main J-frame in which we're doing our graphical display. So we're going to save that in here so that we have access to the paint methods, variables in particular. There's our polls array, there's the poll length array. We're going to keep track of the number of moves. The towers is going to construct this main thread. Okay, so main thread extends thread. It's going to run by itself. And towers is going to construct that in its main program. It's going to create a new towers. Sorry, it's going to create a new main thread, and then it's going to start it. All right, so the run method is pretty straightforward. We initialize the poll setup, so basically for however many disks we have, which we get from the J-frame class, towers, we set the disk information on poll 0 to be just the number of disks, right? The number of disks minus I, so we just go from 1, 2, 3. This just reverses the order of them. And we set the poll length to the number of disks. The other poll lengths we set to 0. So all the disks start on one poll. We set a flag showing that we're running, and then we say solve for that number of disks moving from poll 0 to poll 1. And the solver we already looked at. And then the show move to actually display what's happening graphically. So first we update the polls information. So we take the polls on the poll that we're moving to. Could have used different variable names. We take the polls variable on the poll that we're moving to and increment the poll length by 1, right? And we store the disk that's coming from the poll we're moving from the last place on that, which was the old poll length of from. It works. But you have to write these things out and see that this works. But basically, we're moving from to 2. We pick up the last disk on here. That's going to be the topmost disk. And we move it to become the topmost disk on the target poll. And we adjust the poll length accordingly. And that updates this data structure. And then we call save data, which passes this information to the J-frame class. And then we say repaint. And then we sleep for a little bit of time. And we just keep, and we return from there. So every time we show a move, instead of printing, we update the display of the disks, and we call repaint.
You sleep so that you and I can see it.
Yeah. And the amount we sleep is based on a variable that we get from the J-frame class. So the J-frame looks like this. All right, it's got a speed slider, it's got a turbo button like all good machines. We can pick how many disks we want. It'll tell us how many moves we have, and we have a go button to start the action. And this is not a whole lot of particular code in here. It's mostly automatically set up to handle the widgets. So we have our arrays of polls and poll length. We set the running flag to false because we haven't hit the go button yet. Initialize the speed to 2500, so smaller speed is going to be faster because this is the delay between moves. initialize the number of moves, set the turbo button to be false. If we want to know what the current speed is, we check the turbo button. If it's true, we return 0. Otherwise, we return the value from the slider, the current speed. This is the method that saves the pole information locally. This parses that text window that says how many disks we want, turns it into an integer and returns that. All right? So all these methods so that the main thread doesn't need to worry about how do you figure out how many disks you have. Did you type it in? Are you putting it in a text window? Or are you using a slider? It just calls the numDisks method and it gets the value. And then the paint method is actually really simple. We draw 3 red poles. But the tricky part is this business in here, right? So y 898, 340 minus 16 times 5, 4, and 5 times 16 plus 3. Graph paper and pencil are your friend here, right? So you'll do some of this in PA3 with your tic-tac-toe board. And anytime you're doing sort of barehanded graphics, you end up doing these kinds of calculations. So you decide, you know, how big is this playing field going to be? Where do I want these things located? But ultimately, to draw these, I need to know x and y coordinates for the beginning of these lines. And if I'm making them thicker than just one line, I need to know x and y coordinates for lower left and upper right. And seriously, you get a piece of graph paper and you make a mock-up of this, right? And you end up with these crazy magic numbers, right? But for example, I put 16 times 5 in there instead of 80, and I did 340 minus 16 times 5 instead of 260. Why did I do that? Well, I don't remember at the moment. But it had to do with the idea that I wanted this thing to be, these poles to be far enough apart that a certain size disk would still fit. And my disks increase by 5 each time I have another disk, and I think I wanted a maximum of 16 disks. So that's the 16 times 5, and then I subtracted from something that said what's the range of pixels where this thing is going to occupy space with its largest disk. And it's just one of those things that if you like attention to detail, you can totally groove on this stuff. If you hate attention to detail, you know, you find a friend who likes it and say, hey, how would you do this? And then same thing down here. So that draws the 3 posts that we're moving on. And this checks to see if we've actually started running. If we haven't, then pole length is set to null. So I construct it after you hit the go button. So I just kick out. Otherwise, we go for each of the 3 poles, we go through each of the disks on each pole. So that's poles bracket P bracket I. I set the color semi-randomly based on the disk number. I reduce that modulo 8. That gives me a number from 0 to 7, and I set the color based on that index. So I'll get a tutti frutti stacking of disks. Makes it more fun to follow what's going on. And then this is what draws the disk. So I set width equal to the width of the disk, and it's just 5 times the disk number. Okay, and that's actually the radius of the disk. So the whole thing is going to be 2 times that. And then more special values here, right? So it looks like I set these to be 300 apart from each other. And that's what this 300 times the pole number is about. But I do pole number plus 1, so this is actually sitting at x equals 300, x equals 600, x equals 900. So pole 2, this would be 900. And then I subtract the width of the disk. That gives me the lower left x coordinate for drawing this thin rectangle that represents the disk, and so on. And the height depends on how many things are on the pole. And each time you have something else on the pole, you increase by whatever the thickness of these disks are. And lots of trial and error, lots of pictures. But you figure out sort of, your brain figures out how to do this kind of thing pretty quickly. So that fills a rectangle that corresponds to the disk, and that's really all there is to painting the picture of what's going on. And then the rest of this is just interacting with the widgets. So when you hit the go button, it creates a new main thread and it calls the start method. Yeah.
Real quick, so the only way to make your line thicker is by giving it a secondary.
No, so if you use graphics 2D instead of graphics, you can set line attributes, and one of them is thickness.
I'm thinking about for the X's and O's.
Yeah, single line is pretty thin,
Mm-hmm.
so you can set attributes to make them thicker.
So was it graphics too?
Graphics 2D. And it extends graphics, so you've got everything that was available in the graphics class. But there's a set stroke. So there's a whole class called stroke, and stroke will let you set things like thickness and dashed patterns and things like that. And I think it's a basic stroke. So you can do end caps, you can do width, you can do bevels and miters and rounds for joining lines, and you can do dash attributes.
Is there a method built in to make the line strub?
Strub.
To blink?
Hmm?
To blink?
Oh.
Yeah, or is that something we have to build ourselves?
I don't know if there's a way to do that. There should be, you
To
know.
make the most visually annoying
Yeah.
targeted wordplay.
There should be, but I don't know if there is. Google it. But you could have more fun doing it yourself because you make things blink at different rates and stuff like that. Or have
That's to
it,
put an epilepsy disclaimer in this case.
yeah. Or have it stop blinking every time you look away. you
Oh my
know.
god. Yeah, reading the cameras.
Yeah,
Do you pass in graphics 2D into Paint,
I believe so.
and it works the same? And
Yeah.
the same for Super.Paint?
I think so. Let me know if that doesn't, but I'm pretty sure that's how you do
Yeah, I'm
it.
probably gonna try that because it's just like the lines are so skinny and
Yeah, yeah.
ugly.
So this has got a J slider, right? And sliders come with methods, so you can set the size of a tick, you can set the max and min values, and so on. And how you want it to look, and so on. And then an event handler basically says when the slider changes, I say get source, cast it to a J slider, that gives me a source. I say get value, that gives me the current value of the slider. And then I do some more arithmetic. I find out where I am between the maximum and the minimum, and that becomes my current speed. So that just gives me a number that corresponds to the slider position. That sets me the speed, and I set the maximum to 2,000, minimum to 0, and the default value of 1,000. And then there's a label that's speed. I just put that out in Window Builder. There's a label that says moves, and there's a turbo button, and when you click the turbo button, it just toggles the turbo flag. And not a whole lot else. Oh, so if you change the number of disks, then it'll go ahead and redo the initialization and set up the game board to look correct. And default number of disks is 8, and that's pretty much all there is to it. So with all of that, let's go ahead and look at this. So 8 disks. And let's run this. So it's just going through this recursive algorithm. It's basically moving the first 3 disks over to there, moves the 4th disk, and then moves the top 3 disks back to the middle pole. And there it's done, and now it will continue doing this. And we can speed this up.
What's the turbo?
There we go. Turbo makes it go really fast. So if we do 16 disks, Turbo still makes it go pretty fast, but it is doing something. If we go 24 discs, that's the turbo speed. So 24 will take you 16 million moves.
So those guys that have to move all those discs are gonna be there a while.
Yeah.
That's good.
Probably generations. So.
Someone needs to build one of these with a robotic arm. We can put it in the display case and just do this all day and all night.
For
I'm
years to come.
totally sure the school will totally be happy with, that robot arm using electricity.
Absolutely. I'll fight for it, man.
The business department can create power generated.
Yeah. No, that would be an awesome display, right? If people walk by, like, what's that doing? And it's programming and it's mechanics and it's physical interface and it's STEM, man.
University has
Running
the
since
world's
the
longest
1990s
running
and it's still not
experiment,
done.
pitch experiment.
Yeah.
And they're measuring the viscosity of pitch, and this thing has been going for over 150 years.
Oh, wow,
Dripping
cool.
into another container.
Nice.
So you can have that thing running for
Yeah,
almost 5. and
It's
make a case for
steam
it.
at its finest.
Well, Clark is over.
Yeah, exactly.
No, when it's done, you just add another disc and
Yeah.
do it all over
Oh.
again.
We could have a ceremony with that too. Be like,
The
Oh, yeah.
changing of the.
Is
The
it
adding of
finishing?
a disc.
It's finishing.
Yeah.
3 hours until it finishes countdown.
In fact, you could have it like send out Twitter updates automatically every like million moves or
I mean, you
something.
can calculate how long it would take for it to like, play
Oh,
through an
wait.
entire year.
Oh, it'll take a
Just
while.
Use like that as the ball dropping.
Oh yeah, totally. That would be sweet.
Would there be any copyright issues with using Rob the robot to do it?
Oh, I don't know.
Because that's like what he's built for.
Yeah. And if you really like the fields and wave stuff, you could probably do this magnetically. You could probably get a way to like get a disc to levitate and move over. That would be really cool.
I'm 100% sure Clark would have no problem allowing you to
I think
do
I
that.
I guarantee I would be a fan. I think it would be really cool. So 32 won't finish, right? That's going to be 4 billion moves. So the display flickers, right? And it's flickering because every time that we go into paint, we call the superclasses paint. And part of the superclass paint clears the display. Right? Now, when that go button gets erased and redrawn, it seems to look solid because it might disappear briefly, but then it comes back. But it takes a while to draw these discs, and when they disappear from the superclass, it's long enough for them to reappear sometimes that our eyes notice it, and it comes across as flickering, just like with that rectangle when it was growing and shrinking, we saw it flickering.
So you're repainting the whole, like.
So I believe that's what the Superclass Paint does.
Because even moves was flickering.
So down here we're doing the Super Paint. So if we get rid of that and we run it, and we gotta like find our widgets still. There we go. And we'll do 32 discs and we'll do turbo mode. Alright. It's pretty solid and it kinda looks cool.
The aliens
But
are
even moves
taking
is
over.
moves
Looks
is
like the
thinking,
poles
oh,
just
You can see the progress that it's making now.
Yeah. And yeah, you can see flickering and moves, right? So, I mean, it is redrawing.
What is this? Atari 2600?
I don't know how I'm displaying moves. I'm
That's
not
a
sure
pretty
why
sweet
that
pattern.
flicks.
This would be a cool T-shirt to sell.
Yeah,
with the
yeah.
logo.
The
Especially if it
pyramids are
changes
building
while you were, like-
themselves.
Sci-fi
It's the great pyramids of computer science.
You know,
The
you can
towers
get,
are taller than the pole though.
yeah, it was made for 16 discs. If you could put this on a T-shirt that actually changed while you were wearing it, that would be cool. There's e-textiles that'll let you do that. But I mean, this looks much more solid, right? Because it's really just drawing the updates. Now, somebody mentioned before the poles are flickering, right? But that's because the poles are being overwritten by the discs. So if you remember the code, the first thing it's doing is it's drawing the poles, and then it goes ahead and it draws the discs.
It's way faster this way.
So if the poles appear briefly and your eye sees it, and then it draws the discs and the poles disappear, we're picking that up visually. And yeah, this should be faster because it's not doing all the stuff to repaint the buttons and so on.
So this could be a super turbo.
Need a super turbo, yeah. So you can make one that like suppresses, every million, only shows you every millionth update or something, and that'll go faster. And 32, 2 to the 32nd, that's 4 billion moves. That's doable, in an hour-long class. But with the frame updates, not so much. So if you didn't want this to flicker, typically what you do is you've got your, right, remember the cathode ray tube image with the thing repainting the display, right? So same kind of idea, right? You're updating your pixels. If you were to wait until the entire screen was drawn, and then before you start redrawing the pixels the next time, you go ahead and you update all the pixel information. Then when you go through and you display it, you're seeing a consistent image. It doesn't change halfway through. The problem here is you start drawing the pixels and you get the top half of the pixels displayed, and now your information changes and the bottom half of what you're drawing is not consistent with the top half. I'm picking on half randomly. And so you get this jaggedy flickering appearance, yeah. So if you redraw 60 times a second, right, you could do one update per refresh, but you'd be getting 60 updates per second. So to do a million updates, well, to do 60 million updates would be a million seconds, right? So several hundred hours. So that's not quite feasible. This is actually making decent progress.
Is it 4 billion?
Should be 4 billion, yeah. So it's actually getting there.
Almost there.
The trick, though, is when you get down to only having one disc left, you're only halfway through. And if you've only got 2 discs left, you're only a quarter of the way through. And if you actually got 3 discs left, you're only an eighth of the way through. And I can't tell what numbers these are.
300 million.
Yeah, it's only 300 million. So it's only a tenth of the way done, which kind of makes sense because you've got 3 or 4 discs that haven't changed on the bottom.
So its final look is going to be 3 full towers.
Its final look, yeah, I don't know what it looks like in the end. Well, let's kill this and try it for 24. That's a really good question.
Shake the edge of sketch.
Yeah.
Can you put an I regret this button on there?
I don't think
Put a
so.
what?
Like,
Put an I regret my decision button on there to stop it.
Just to restart.
Just to kill it.
there you go.
There we
Yeah.
go. Yeah. Alright, so that'll go quickly. Yeah.
Turbo would be making a whining noise.
Yeah, right. There you go.
Program should do that, right?
Cool.
So not 3 full towers.
There's all
So,
there's
Yeah,
all
middle one
disc-
should be full.
disc
So,
carcasses.
the 2 on the side are patchwork towers, and then 1 full tower.
And what's the difference between the left and the right?
The
The right
left one
side.
looks like it has a face on it to me.
Yeah.
The left has a lot more gray than the one on the right.
Yeah, there should be some nice relationship between those.
I think the left one should consider be full though, right?
No, left one's missing the cap.
Yeah,
Right
besides the
one's
cap,
also-
it's just the first move.
No, it's missing the base dome. Because when you move the base,
Oh, yeah.
Yeah, because you never move the very bottom one to the far right. You only move it to the
Right.
middle.
And the right one has.
But the left one started with all of them though.
yeah, but
Yeah.
when you moved it from the left redrew it without it there.
Yeah.
And let's just for comparison do 16. This is not on the test. I gotta clear it. This is tricky.
So your discs are set as a fixed
There we
height and not a proportional height?
Yeah.
Yes. So that's the story with 16.
Let me see if that is proportional.
So how do we deal with this no components showing up in the beginning business? Any ideas?
Email you about it.
Professor Nick, nothing's showing up when I try to launch my program.
Yeah. I mean, we're supposed to call the Superclass Paint in our paint method, but if we're not doing that for some reason, we have this problem that none of our components are showing up. Is there anything we can do about it?
All super paint.
Yeah. When should we do that?
At the beginning of,
Yeah.
So I was gonna put a button on that said repaint, but if the button doesn't show up, that doesn't help us. But,
You gotta find it.
yeah, exactly. But how about when we, let's try components shown. See if we can get lucky.
so it says if the components are shown.
Yeah, so I put this on the J-frame. So maybe this will repaint when the J-frame gets shown, but I don't know if that's too early. We can put it on resize, but let's see if we can be more nuanced. Nope. So let's put it on resize.
You could do mouse click too, right, and just click anywhere in it.
Oh, that's true. Let's do mouse clicked. Or paint. Click.
Oh.
Oh, do not. Oh,
Wait, that's
it's not
component shown,
repaint.
you deleted the old one. Listener. Should be mouse clicked instead of component shown. Yeah.
Alright.
yeah, but repaint's not gonna do it for us. So, here's what we gotta do. So let's set a flag called paint all and set it to be true. And up here, let's make a flag.
What is your running flag up there for?
Brilliant.
Make a paint all.
The lean flag.
And then when we go into our paint method, which I can't find. Whoa, what is going on?
Oh, do a colon first?
I'm not in VI anymore. That's why this font is strange.
I thought with VRapper it wouldn't let you do anything other than colon start to get the basic command.
No, it should be full bore. But anyway,
If I had the old fashioned way.
shout when you see the paint method.
Control F, how to do it. Maybe.
So maybe we should just do super dot paint.
Right, so, and I can only do super.paint inside my paint class because that's where I have access to the graphics object. So I'm just going to use this repaint all flag, which I apparently called something else. I think I called it force
Paint
paint. Paint all.
Why is it so fun to say typos out loud?
Yeah, no.
So do you still want that as component shown?
Yeah, let's try it as component shown. We'll move it if
Yeah, 'cause that's definitely
that
preferable.
doesn't work. Nope.
Look, already.
So let's do this on resize. Oh, we're going to do mouse click, right?
Yep. Except for you can just click on the J
can
frame,
just do
right?
mouse
Not the
enter.
panel.
Does it matter if it's the frame and pen?
I was going to do it in the frame.
Makes sense, 'cause that means you do click on the panel and it'll still be true.
Alright, so there's our window, there's our click.
Oh, snap.
Yeah.
Very nice. That's a nice trick.
Yeah.
Do you have that problem if you just call super paint?
No, if you call super paint, this is not a problem at all.
So,
But then we got the flickering.
So why did the repaint not work? Why did you have to have a flag?
Cause repaint is just doing exactly what repaint does, which is not doing the super paint. right? So the way we get these components to appear is by calling the Superclass Paint method, which is really, really hard for me to find for some reason because it's up here. So it's this that's actually drawing those components. So if we just call, right, because we commented out super.paint.
Okay.
So if you just call repaint, it just forces this code to run, but it's still not painting the super with the superclasses paint. So we set a flag that basically said if that flag's set, then go ahead and call the superclass paint method, and then clear the flag so it only does it once. So the next time we paint, it'll just do what we've got in here.
But you're not returning, so it'll still run the rest of the code.
Yeah, yeah.
What if you could somehow put like collision detection in to get rid of the? You wouldn't have to clear. You just only have to draw when you need to.
Yeah, you can get arbitrarily fancy.
That sounds like Patrick.
Yeah. So another thing here. So we were drawing the poles, and then we're drawing the discs.
You guys want to remake?
And when the disc is drawn, right, this little section of the pole changes from red to whatever the color of the disc is, right, and that causes some visual clutter. So in the graphics class, there was a way to set what operation we wanted it to perform when it drew a pixel. Do we want it to replace the pixel that's there or do something different? And this is where this can come in handy. So the current logical pixel operation function XOR or paint. So if you do an XOR, right, you got to go back to 250 here. When you XOR, you get that funny kind of truth table, right? So one way to think of an XOR, if you take A and you XOR with 0, it's a no-op. 0 becomes a 0, 1 becomes a 1. If you take A and you XOR with a 1, it becomes an inverse. So if you have a line and you draw another line on top of it, with a paint, this second line simply replaces whatever the first line was. With an XOR, this point where it crosses will be, if it was a 1-bit pixel value, it'll be complemented where it crosses. And then if you were to remove this line, it will go back to the original value because it will complement again. And so it's a way that you can draw things that overlap each other, but that change the color of the pixels basically where they overlap, or changes the value of the pixels where they overlap, so that you don't actually lose the information of the thing that you crossed over.
It's like a black and a white line might be gray or something.
So it might be gray or something like that, but in reality we don't do this with the colors, we do this with the index table. Did we talk about index table animation? Lookup table animation? We're going to talk about that right after break. Did you have a question? Okay. All right, let's take a 5-minute break. I'll tell you about lookup table animation because it's apropos to these graphics discussions.
Because then you can still tell that the polls are
How's it coming over there?